Now, we are recording. Uh, Welcome to the evening of Python coding. It's the last one for 2020 this year. However, we have perhaps one of the most spectacular presentations this time to finish the year with fireworks. You will see why in a minute. When I mean see, you will see. We have James Bednar, who presented here before something similar, but now he's going to present something called hvplot, which will enhance some of the things that you've seen in the past. James is from Anaconda, and he's the head of this Holovis project. And James, without me talking so much, take it here and tell them what it's all about.
All right. Thank you, Jacob. Yeah, I am at Anaconda. Before that, I was a lecturer and reader at the University of Edinburgh for 10 years. And a lot of these ideas actually started there. I switched to Python when I got my first faculty job, and I decided I was tired of doing C and that I wasn't going to make anyone else ever learn C. So when any new student I got, I made them learn Python instead. And I learned Python at the same time. That was starting in 2004. And so some of the libraries that underpin what I'm showing here actually started in right around then, in 2004. And so some of these go very far back. But what I'll present today is a much more recent library called hvplot. Let me go ahead and present. hvplot is kind of a deceptively simple library. And what that means is that it looks straightforward, and hopefully it's straightforward to use, but it's built on a lot. It's building and drawing in a lot of things, and the stack that it's built on goes very deep. And that's both good and bad. It's good in that it's very powerful. It's bad in that there are a lot of moving parts here, and it's possible that you can get an error message and you have no idea where that came from. So just bear that in mind. This is super high level stuff at the very top of the stack, and it goes very deep below it. But specifically, the goal of hvplot is to help you build visualizations, and now, as of today, dashboards using APIs that you already know if you're a Python data scientist. And so I'll explain what that means. Yeah, there's my title there. I'm a senior manager of technical services in Anaconda. What that means is that I work with our corporate and government clients doing custom services for them. And specifically, almost all the work we do is that client has a need, and we say, hey, what if we solved your need with this open source tool plus a little bit extra stuff on top? And so each time we have a contract, we end up doing some custom work for that client and a lot of work on the underlying tool just to make sure that it's more general, has more power, and actually solves what they're trying to do. And that way, every new contract we get, the tools get better, the clients are happy, and so on. That's basically our business model in my group. We take money and we put it back into open source so that any client we're dealing with, they get the power of all the things we've ever done before, plus a little bit of extra work. And together, that's a huge set of power that they get. And they only had to pay for that little bit on top. And the world gets everything for free. So everything we do in my group goes entirely back out into the open source. It's all completely free for everybody. So hvplot, it's one of our, actually these are almost in order chronologically. It's one of our more recent libraries, but not our most recent library. The most recent that has been announced is Panel, and then there's one that we'll announce pretty soon, currently codenamed Lumen, that's newer than Panel. But hvplot is one of the newest. Like all the rest of them, it's free, it's open source, and it's Python. And what it does is take an API that we did not write and then makes it extremely powerful. And specifically, it does that with two different APIs, but one of them is the Pandas Plot API. So if you have a Pandas data frame and you can look at a data frame, then you can call .plot on it and get a plot out of it. Here you can call .hvplot and using all the same keywords and such, but get a much more powerful plot. And I'll show you why it's more powerful. That's the first part. And then the second part is what's new in today's release, although it probably will appear actually on the sites tomorrow. But you can use the same tools in the same Pandas API or native API in general, not just Pandas. I'll explain that, to build applications and dashboards. And hvplot is part of the holoviz.org suite of composable tools. And some of these libraries down here, these are all different holoviz tools. hvplot is a little bit special in that if you use hvplot, you can kind of pretend those other ones don't exist. So it's built on everything to the right of it. Actually, it's built on panel 2. So hvplot is built on everything else. But you can try to get away with at least not knowing or learning about the rest. hvplot is the first thing we would recommend people go to. So here's just an example of some things you can create with hvplot, various types of plots. Just to make sure that I'm still actually being heard, is Jacob, can you hear? And is everything okay on sound-wise?
You're okay sound-wise. You're doing fine. I hear you well. I hope
Very
John
good.
hears you well as well. So.
Okay. So I won't go into these specific examples, but you'll see things like that in the next plot and next few slides. But the idea here is that each one of these is about a line or two of Python code, because each one of them is a particular type of plot, a particular thing that can already be done ahead of time. There's not that much new that you have to do unless you want to heavily customize it. And so it's possible to add arbitrarily many lines of code if you want to get all the details exactly as you like them. But the goal of hvplot is to give you a plot immediately that is pretty good, and then you can tweak and tweak to your heart's content. But you should be able to see things visually immediately, and then work on tweaking, rather than work for a long time and finally see something. Because basically our philosophy is that unless data is super easy to visualize, you won't do it. And unless you do it, you won't have any idea what your data is. And so you'll be flying blind. If you have a program that requires you to work for a week before you get a visualization, you 100% are not going to understand your data, because you're going to work for a week and do something, and you've got a pretty plot. But what about all the other bits of the data that you weren't showing? Every different combination, you don't know what's in there. You have no idea, because it's too hard to build a visualization. It's got to be super easy and super intuitive to explore your data visually, or else you'll never understand your data. As a scientist, that's what I was for 10 years. Now I'm a computer programmer and a manager. But before that, I was actually trying to do science, and it's just incredible how many people don't understand their data sets, make wrong conclusions because they don't actually see it. They haven't seen what the real data is. It's thrown off by outliers, thrown off by trends they don't know. Unless you can see it, you are not doing what you think you're doing. So we're trying to make it super easy to do plots like this. So how that fits in here is that you've got to start somewhere, and you start before hvplot. You grab one of these libraries here to put your data into. You have some file on disk. You've got to load that file into something in Python. You can load it into one of these things, any of these things. It doesn't matter. Well, it matters a lot. hvplot doesn't care which one you do, but you have to choose the right one for your data. If you have multidimensional data, like a stack of microscope images, that'd be X-array, or climate satellite imagery, that'd be X-array. If you have a bunch of tables of numbers, that'd be pandas. Tables of shapes, that'd be geopandas. If you wanted to use this on a GPU, you'd use Rapids. If you wanted to distribute it across lots of processors, you'd use Dask. If you want to have network data, you would use NetworkX. If you wanted to have a whole suite of data catalog data where you're choosing things from a catalog, you'd use Intake. And Intake can use any of these other tools. Rapids can use most of these other tools, and so on. So that's up to you. How you represent your data, you need to make the right choice for the type of data you have, and then you move on. Make that choice, pick something, and then you can call whatever it is, you can call .hvplot on it. And then that'll generate something that goes to the right in this plot here. It creates what's a HoloViews object. So it's basically a mapping from your data into a HoloViews object. A HoloViews object is what Jacob is using directly. hvplot is a super quick shortcut to get them. And then once you have them, this is an intermediate representation where you've basically taken your data and you've annotated it with a little bit of metadata that allows it to be visualized, but doesn't visualize it yet. And that's super crucial, because hvplot, I mean, it's called hvplot, it doesn't really create plots. It creates plottable objects, objects that could be plotted if you wanted to. And at that point, you can do a lot with them. You can actually get the data right back out of it if you wanted to. Don't plot it, just pull the actual numbers out. They're still there. Or you can plot it an entirely different way, which is this pathway down here, where this is a program we have called Data Shader. This does server-side rendering, which is this object might exist on some server. It might go to data shader, it'll turn it into an image, and that'll go down to your web browser. That's an entirely different pathway than the typical pathway, which is that the data is in memory and the data is sent to your web browser. So the typical pathway is you got this visualizable object and it's sent to your web browser, and your web browser uses JavaScript and shows you in your web browser. But because we've captured this data in a visualizable way, we can do anything we want with it. We can analyze it, we can do various pipelines, and in particular, we can render it off screen, as it were, and show that. If none of what I said makes sense, don't worry about it. This one's a big logo because that's the one you need to remember. Use hvplot and then worry about the rest.
So I got a question. So I saw the previous slide you had like GeoViews, like where GeoViews would plug in here.
GeoViews is exactly the same as HoloViews, except that it's extended to convert latitude and longitude into various projections. Because those latitude and longitude are on a sphere, but your screen is not a sphere. So it has to, there are various assumptions it makes to flatten that and wrap that onto a screen. GeoViews encapsulate those, and it does so for two reasons. One is it's domain specific to geographic data, and HoloViews is not. HoloViews is everything. And the other is the tools it uses to do this are legacy tools that have been around for decades. They're based on Fortran, they're based on C, they're hard to install. And so if you want to do those things, then you can. Otherwise, if HoloViews is enough, stick with HoloViews. If you desperately need some of the extra functionality of GeoViews, you can do it. But you don't have to use GeoViews just because you have geodata. You have to use GeoViews if you have obscure and weird geodata.
Okay.
Like if you really want to transform it in all sorts of weird ways.
Yeah. Cool.
So you can ignore GeoViews most of the time. And I think in my list here, we've already mentioned hvplot, HoloViews, GViews, data shader, and I won't mention param and color set, and then maybe we'll talk a little bit about panel. Oh, we definitely will. Okay, so really as a user, if you're thinking about tools on a shelf, you got all these tools on a shelf, which one do you pick? We suggest you pick hvplot. That's a very good starting point. So grab hvplot and try to use it, and only then worry about all the details, because those details give you a lot of power, but you can get a long way without learning that power. You don't need to know their APIs. You don't need to know much about them. Just stick with hvplot, and if that's enough, you never have to learn anything more. And that's the whole point of hvplot, is to be able to use the knowledge you already have if you are a Pandas user or an Xarray user or Pandas or Dask user. If you use any of these tools already, you already know their APIs, and you have to use them because otherwise you can't get your data in Python. So we've made hvplot match their API so that you don't have to learn anything. So that's the short story, actually, what we're doing here. Somebody was wondering about my email. It's jbednar@anaconda.com. That's on your screen there. That's meant to go at the end, but all right. Because the rest of this is just taking you through actually using it. And this is all stuff that is that should be on the website. I'll first go just through the introduction. There's another section here called interactive that is not on the website today. It'll probably be on the website tomorrow. This is brand new material, so you're the first to see it. So I'm doing two things that will be on the website, one of which is already there. So if you just follow the Getting Started guide at hvplot, you can do all of this yourself. It tells you how to install things and use them. And then I'll just go through what happens after you've installed it and run it. And basically, you get a set of Jupyter notebooks, and everything on the website here, these are all just Jupyter notebooks. So they look like a web page, but behind it, it's really just a rendering of a Jupyter notebook, and that's a code cell, and this is an output cell. I mean, the output from that cell. So I'll switch to Jupyter. So everything after here, you can just follow the instructions at hvplot.holoviz.org and go through yourself. Although the second half of it requires the GitHub version, or for you to wait until tomorrow. So let's say I've launched Jupyter and I click on the user guide. I'll first go to the introduction. This is just the simplest introduction to the API. And just start from the top, and I'll go from there. So at the top, you have to get your data in somehow. In this particular example, we use Pandas, but like I said before, there are lots of other things, and they all basically work the same. It doesn't It doesn't depend a lot on which library you choose. So you choose your library for the data, and then hvplot is the same. So here we just made a bunch of random numbers to start with. It's very boring, but it's a data frame with a bunch of columns and dates and values. So this part is nothing to do with HoloViz or hvplot or anything we're doing. It's just NumPy and Pandas, and that can get you some data. And if you use those libraries, you can use with built-in plotting. This is the Pandas.plot interface. And if you do that, you can see that, oh, it's plotting these 4 streams of random numbers. They all started at 0. This is a cumulative sum here. So they're all starting at the same value of 0, and they're basically doing a random walk away from there. And that's why it has this particular shape. You can see there are 4 columns of data. It's plotted across time, and they're each colored by the column number A, B, C, D. Hopefully that makes sense. This is just basic things that we didn't do that are provided with the library. But if you look at this plot, this is actually an image. This is just a PNG, so I could drop it into an email and it'd be a PNG. That's all I can do, though. I can just grab it there. What we're trying to do is add a lot more power and functionality without having to learn anything more. Here, what we've done is import hvplot. And hvplot is built it's not primarily built on matplotlib, although we do have some matplotlib support. This is all matplotlib. hvplot is mostly built on Bokeh, and Bokeh provides similar looking plotting, but it's an interactive plot now. So you can use hover, you can zoom and see all the details with no additional cost. You basically don't have to learn anything new. You just swap it out. And it supports basically the same API. So if you're going to learn something, this is a good API to learn, because there are actually 6 or 7 different libraries. I should if you go to pyviz.org, I think it's currently down, but it does list lots and lots of libraries that are all based on the Pandas.plot API. It'll talk about them. hvplot is one of those, one of the earliest ones, but there are lots. Okay, so this is the idea here is that it should be easy to plot your data, and you should have as much power as you could get for free. And here you immediately get the power to see any data points, and that's fine. What else can you do with it? Here, let's see. I made that. Let me just move ahead a little bit. Okay, so that basically that gets you to the point of having a plot of any sort. And if you look at hvplot's website, you can see there are a whole bunch of different notebooks full of stuff. So I'll just look at one more briefly for a little bit, and then I'll just go ahead and run all in the interest of time, so that I don't have to execute each individual cell. Oops, I don't have that one. Oh, I can't run this one. I don't have these 2 libraries installed, but I won't worry about it. We don't have too much time to go through that one anyway. But if you just look at hvplot, you'll see that there are a lot of different types of plots that you can do, and different things you can customize on it. What I want to get to, though, is the new stuff today, which is this interactive library. And so this is a new feature of hvplot. The previous ones you can explore on the website. It'll basically tell you how to do plotting. It's great. This part is going to tell you how to do building an application from within hvplot without having to learn anything just about. So here, let's load some data to start with, and I'll show you how that works. So here I'm using Xarray instead of Pandas, and Xarray, like I said, was really useful for multidimensional data. And so it's what that means is you've got X, Y, time, temperature, everything, a huge grid of data, multidimensional grid, and you can plot anything. In this case, it's latitude, longitude, time, and air temperature, but it could be pressure, it could be all sorts of other quantities measured on this grid. Oh, it sounds like I'm getting dinner delivered. Just a second. Yeah. Anyway, my daughter is bringing me dinner. I'll eat in a second when I'm done talking.
And all the messages that pop up.
All right, so we've got this data set, and this is the data set of latitude, longitude, time, and then those are the coordinates. That tells you where there is data, but the actual data that's there, in this case, is the air temperature. So now let's say you've learned Pandas, or you've learned X-ray, or learned any of these other data libraries. You already know their APIs. What we've done now is to let you use their APIs and not have to learn HoloView's API, not have to learn any of our APIs. We love our APIs, but it's much better if you already know another API to use it. So we're showing you, what I'm showing you here is how you can use this new feature, Interactive, to use the API you already know and create an interactive app immediately. And so in this case, look what I've done here. If I just write this function here, instead of saying time equals a slider, I could say time equals some time. I'd have to figure out how to write a time. But if I did that, oh, there you go. That's how you write a time. So if I do this, I get something that's not interactive. Hopefully you can see that. I started with my data set that I loaded up here. I selected the air from it. Actually, I can take that off. If I just take my data set and I select the first item in it, it turns out that that's a set of data on latitude and longitude at a particular time. That's the first thing that's in this data set. And if I plotted it, you could see what that is. Okay, that's what that is. So basically I pulled out the first thing at the first time, and it's a plot of latitude, longitude, and air temperature. But here what I did was I added .interactive, and then I told it to select not a particular time, not time 0, but I gave it a slider. So here I created a slider. It's an integer slider. It starts at 0 and ends at 10. Starts at 0, ends at 10, and then I pass that in as the value for time. And now when I select something, I can actually immediately select what I want with the slider instead of having to type Python code.
Can you visualize it? Like, can you maybe use the slider and visualize it in the real time?
What's that?
Can you like visualize it maybe in real time? Like use the slider and maybe, I don't know how the plot will look like if you slide.
Oh yeah, that's the next slide here. So let's well, that's the next after it. So here I'm using actually this slider here comes from the library Panel that I said I was going to mention. Panel is how we build apps, but then you have to learn Panel's API. Here you don't even have to know Panel's API. You just have to get a widget from Panel, and then you can plug that in here. And here we're getting a textual output, but now let's go ahead and we can actually use widgets from IPython. That's just a different widget library, and that'll also work if I've set that up. Let's see, IPython. No, that's weird. Not working at the moment. But then I can also go ahead and plot it. Here. So here's that same data now plotted with, all I did is call .plot on it. And so this is the same series of data, and all I'm doing is selecting which time I want to plot. And I select it by passing in this slider, and then I call .plot. The .plot in this case is a matplotlib plot, and so you can see in this case, we're telling matplotlib just to make a PNG. We can do the same thing with hvplot. So this is based on hvplot, but it's using hvplot in two different ways. One is to get this ability to have a slider, and the other is to do the plot. So now I converted that matplotlib plot into an hvplot, and now it's a bokeh-based plot with a slider. So
can you hover
again,
over it? Can you?
Yeah.
Yeah. So now you can actually see what you're looking at.
Yep, and you can zoom. There's not much detail in this data, but in a bigger data set, you would find more detail when you zoom.
So you're rushing here. I want people to capture, understand what you're showing, because you're kind of skipping on some of the things that they may not understand. So how many dimensions does this plot have currently?
I think it was 4. Let me check.
No, you're showing 4 dimensions on screen. You're showing X, Y. The
yeah,
color is the
longer
third one.
Y. The time, the air is as color, and the time is as a widget. So let me go back to it. That's actually showing all the data that's in this right now. So it's latitude, longitude. This one is air temperature in Kelvin, it looks like. And the last dimension is time. So there were 4 dimensions. 3 of them fit on the screen, X, Y, and color. And the 4th dimension is a widget.
So usually people used to look at 2 dimensions at a time, XY plots. This shows 4 with the ability to interact. And how many lines of code did you use?
1.
Ah.
In this case, it actually, I didn't define, here it's actually figuring out, I didn't define discrete slider. That's just a type of object. And a discrete slider actually looks at the data and figures out all the times that are available. So in this case, this is the only line of code after loading the data. I could have skipped everything after this part, just load the data, and then I can do this plot. So as soon as you load the data, you can do this plot.
So 4 dimensions in one line of code and interactive, so people can now explore the data, correct?
That's right. And you can do this with anything. You could replace it with, instead of time, I don't know, this might work, I don't know. No, it's not an integer. So here, that's an integer slider, a discrete slider, and I'm trying to do floating points, so that didn't work. But here it's saying that for the time value, substitute the value of this slider, and so on. But in general, if you want to look up the right kind of slider, you can replace any of your variables with sliders. And for instance, here it's a 2-dimensional plot. You could replace it. Well, I'll probably have examples down here where I replace it. And take a slice, and so it's a line curve and such. Does that make sense?
Yeah. Go on.
Okay.
I interrupted you because I wanted to people to understand this point, because you were so excited to show the new stuff that the power of all your old stuff almost was forgotten.
Yeah, that's right. This is what my brain is thinking of right now, is this new stuff. And here's an example of some of the other things you could do, which is, this is just a different type of widget. Panel provides Sapiura, panel.holoviz.org. You can click on, there are lots of widgets, it's layouts, templates, widgets. Okay, these are some of the many widgets that you can select. You can pull any of these out and use them in your, and pass them as your argument if they've got the right type. So in this case, it's a player widget, starts from 0 to 10, and it gives you a little CD player style interface to your data. All that is basically the same as your slider here, but in this case, it's a player. You can do the same thing with pretty much any pipeline here. What's really cool here is that once you've typed .interactive, you can type anything at this point, and it's nothing from HoloViews, it's not from hvplot. Who defines quantile? In this case, it's X-array. But if that were pandas, it would be anything defined on a pandas data frame. So here, you're not using our API, you're using Pandas' own API, but we've extended Pandas' own APIs to accept a slider. So instead of putting a number for the quantile, like, I don't know, 70, what does it even want? Actually, it's great when you just do what it takes, because it shows you it detects the value. The quantile is, it's normalized. So the quantile is, so 0.6, let's say.
It's 0.6. You have comma 6.
Oh, whoops, that's why. Sorry. Okay, that's what it's meant to be. So here I'm passing a number for it, but what hvplot allows you to do once you've typed .interactive is pass a slider for it. So here I got no slider. Why did I get no slider? Well, because I chose a value for the quantile. I don't need a slider. But if I pass in a slider, now I get all values for quantile. Any value I want, I can select at that point. And so you can put these anywhere along the way. You can put as many widgets as you want and make it arbitrarily complicated. I can select the time You can select the quantile. In this case, it's actually pulling out. Okay, it's pulling out only the longitude dimension. It's taking the quantile on the longitude dimension, which leaves the latitude dimension. That's why that's here. So here, like I said, you have to choose the right kind of slider for the quantity you're substituting for. So you do have to learn that. But usually you know what that is. You know you're substituting for an integer or a float quantity. And like you just saw, you have to know the range sometimes. But here we built a little app that allows you to explore multiple variables. You can do what you like. You can do
how many of those can you handle?
100, I don't know, whatever fits on your screen.
So you can add many of those slider to look at multidimensional data with, let's say, 50 dimensions, for example?
Yeah, exactly. And and each time you would just have this is a pipeline of operations supported by the data set. Whatever that supports, you can select on one dimension, select on another dimension, do a mean on another dimension, do some sort of aggregation on any other dimension. Just a long series of starting with some data and zeroing in on the thing you want. And at each point along the way, you leave a little control to change your opinion about what you want, how you want to zero in on that multidimensional space.
And what do you have here? This is new, no? The range.
Brand new.
No, the range.
Yeah. Oh yeah, here in this case, it's doing a mean over the range that you're providing it. So it does a selection of a range. So that's basically a filter by time. In this case, it's actually, it's not even a filter by time. It's a filter by the index of the time variable. So that's kind of unintuitive. So the first time value and the last time value. But anyway, you're selecting a range of times. And then in that range of times, then you call the mean of it over time. And that gives you one plot. So you've selected a range, and this plot is the average in that range. So if you keep it wide, you'll notice it doesn't change very much, but once you get it real small, it changes because you're looking at a very narrow time range now. You can do things like that. You can do, you can actually change the type you're doing in the middle of your pipeline. So just to walk this left to right, oh, it's very annoying. I'm gonna have to, so all it is, put it on 2 lines so it shows. So you started with a data set, you selected the air temperature, you made it interactive, then you selected latitude. So here we got a latitude slider, and then we converted it to a data frame, and then we grouped it by time, and then we took the mean across time, and then finally we plotted it with time on the x-axis and air on the y-axis. So in the middle of this, it went from being an X-array data set to a Pandas data frame. But that doesn't matter. What's happening here is that this object is basically storing up everything that follows it, and it replays it every time you drag this. So it doesn't really care what's happening after that. It's just replaying it, and wherever there needs to be something substituted in from the value of the widget, it does. And it only computes the stuff that's to the right of that widget. So if you put something at the end, it would only redo that bit. And again, this is all interactive here. So here we built an app again with 1 line. It didn't quite fit on 1 line. We should probably make it do. You can do more. You can you don't have to. You can actually do math on it. Let's say you've computed a baseline for the air temperature. Now you can take something and compute the mean, and then subtract the baseline automatically. And so here as I drag my widget here, it's just looking at the difference between the value and the baseline at every time. That probably doesn't make any sense, but here normally you'd think you can do math on integers. In this case, it's something that, or floats. In this case, baseline is a float. It's 281, and all it does is, if you didn't have baseline there, it would print a value. And here it's printing a value, but before it prints it, it subtracts the baseline. And so that means you can do a plot the same way. But here we're actually multiplying 2 widgets together. So we can, we're plotting the first one and then adding an offset, and the offset itself is a widget. So you can imagine how you'd put this together into arbitrary computations that you might want to do. Hopefully you can imagine. And so here's doing that with some data. And so what this is doing is selecting the time, is subtracting the mean time. So that's basically a baseline. And then separately, it's letting you select what kind of plot you want, filled contours or images or unfilled contours, but also then selecting the time. And at each time, it then subtracts the mean time. The mean at that time, across time. So the mean across all times are subtracted from the particular time that you're showing. And hopefully you can imagine that the specific example doesn't matter, but in some other cases, it might be, you might want to plot something against something. Well, you can easily do that and just substitute a widget, whatever you're doing.
So James, you're showing a lot of stuff and like it's endless. Let's see if someone.
No, this is the end. This is the last one.
Ah, really? Okay, show us this. But I have a bunch of challenges for you.
Okay, please do. So this is the last one, and I mentioned that these widgets come from panel, and the plots also and the layouts also come from panel. And what that means is that what you've gotten from hvplot in something like this, you can now do work if you want and embed it into an overall app. So here I took what we just did there, I put a little label on it, I put some images beside it, and I laid it out with the widgets in between the images with the plot there. And so you've made this is a dinky little app, but you can imagine making a much more complicated app. And here's the code for that app. You created the plot, you added this widget, you, this is actually not the plot. The first line was not the plot. It was the data, and then you added a plot to that, and then you made a column of a row and a column. All these things are just the image, an extra little spacer, this head, this title, these widgets that from this object we created, another image, and then the actual plot from this part, and put that all together, and that's our app. So that's as far as it goes. That's showing how to use an API you already know to build an app like this. So I'm going to take a bite out of my hamburger and then listen to questions.
Okay, so while you're having questions, so I've been using this set of tools for a few years, not hvplot, but all of the tools that James is showing, and those are really powerful. However, we have a nice audience here, and I would like to try to throw challenges at James, meaning, can this do this, can you do that, and he will show you the closest thing that they did so far. So or something similar. I know that he can handle it, so this is why I'm asking you to have those challenges. So I know that while I was sitting here, John near me, he was thinking about, oh yeah, I want a plot of my blood pressure, and I think that you've shown something very similar upstairs, like what blood pressure changes, and each time if you test it several times each day, then it may hover above and below, and sometimes you need some sort of average. So what's the closest thing that you can do in a few lines of code?
Well, that'd probably be if it's going over an average. Let me see. hvplot has a reference gallery, but it's not complete. So there are some things in the gallery, but we still need to add a lot more to the reference gallery. And the one we need here is called spread, and it doesn't look like we've created one for that, unfortunately.
I show it from other libraries.
Yeah, so hollow views. So everything's built on hollow views, and if you go to that website, that reference gallery is complete. And then spread. There we go. If you had the upper number and the lower number of your reading, you presumably have this range like that. Is that what you're imagining?
Huh? Well, John, what do you think? Is it something that you were asking? Well, he's probably still looking at it. He gets it a few seconds afterwards. So let's go to the next challenge. We'll come back to this.
Okay.
Anyone has a challenge of some sort of data that they want to plot?
I don't have a challenge, but I have a question. can you do all these outside the Jupyter notebook? Let's say I want to make a service website where a customer can go to, and that's not like Jupyter notebook. Can it?
Yes, actually at the very end of that notebook I was just showing you, which was this one, I didn't explain this line here. And what that means, this line is telling you that it actually tells Panel that if you save this notebook and either just use it as a Jupyter notebook file or export it to .py, it doesn't matter, and you do panel serve in the name of this notebook, it won't serve all this other stuff, all that other junk. It serves this one thing that's servable. And so if I were to type panel serve in the name of this notebook, it would have a standalone app that would actually look just like this. So here's this standalone app.
Oh, nice.
And so what I just opened here is a much more ambitious app. We wrote part of this, but most of it's written by these about that. But it's there either way.
Yeah, that's good. Yeah, this is actually very powerful.
Actually, I'd never done that with this particular plot. I made this plot, this app yesterday. It actually looks a lot better than I thought it would. Like it kind of holds together as an app. Yeah, that'll work. Whereas in the original notebook, it kind of looked a little ugly, I thought. It works this way.
I have a quick question about that, actually.
Sure.
Can you add, like, audio files to it? Or, like, you know, so as you scroll through, it kind of gives, like, explanations?
Yep, Panel's reference gallery is complete as well. And so you can put a little audio app that'll have a player down here, and you just press play. Oh, looks like that one's live. Okay, so there's an audio. You just put that wherever you wanted to in the app. Pain.audio.
More challenges, please. This thing can do a lot. They've been doing
That's
it how many years?
The biggest challenge right there is to convey what it can do. It's very hard.
Yeah, and to Florian, I don't use Jupyter, actually, or Silas or Florian. One of you asked if it's related to Jupyter. Well, when I use those tools, I don't use Jupyter. I avoid altogether. I write plain Python text and it works the same.
Okay.
I use either PyCharm, Spider, any editor. You write a Python program, it doesn't matter. Jupyter, it just visualizes it nicer because they have a way to tie it up, so you can actually write those one line of code.
Yeah, I'm thinking more like building some kind of services where people can actually go log into a website and see the results, something like that.
Yep. Here's something that people have built with, I only have one meeting, so I get, let's see.
Yeah, so Sherry's asking if you've done any COVID data.
Oh, I have actually.
Mapping.
I don't remember where I presented that. Let's see, Anaconda.
Sherry, I've done COVID data with those tools.
Yeah, I was gonna say Jacob has done a lot of that.
Yeah, so if you go to anaconda.org/jbednar, there should be I think it's this one, panel galvanized. So I presented, I think, Jacob, you were involved in that, weren't you?
I'm not sure at this point. I'm confused, but maybe. Probably not.
Okay.
I don't remember the specific one.
I think that's the one anyway. And so in that case, it was analyzing the COVID literature, actually, not the COVID data itself, but trying to do data mining on the literature to find trends and outliers and such. So it's downloads a lot of metadata about various COVID papers. And oh, wait a minute, it's probably Holobiz COVID right there. So it's that may be related. But anyway, done a little bit of that, but pretty much everybody in the world jumped on the bandwagon and started doing vids of COVID, and the world got a little flooded with that. So it became very hard to distinguish between just something somebody put out in 10 minutes and something they actually worked hard on and deeply understood. And so we kind of backed away at that point. Like, oh, it's too hard to not get drowned out by the noise.
Yeah, but the tools of the interactivity of the tools allow to show many aspects more. And when you're analyzing COVID, there are those many aspects. So yes, those tools are ultra important. Some of the things I could not show without those tools almost at all. So
Yeah.
I can send you a link later, but it's James's presentation, so time for more questions and challenges. Please do ask. He can answer, believe me.
James, I have a question. Might be on a much more basic level. I'm in a data wrangling course, and we have to use 3 data sets, CSVs, and we're trying to build an analysis of oil production, oil consumption, and military spending. What kind of tool would you use on your website to kind of showcase something like that? Again, it's a lot more simplistic than the things you were kind of going over, but just if I wanted to use one of your tools.
Well, the big clue is that if you have CSV, you probably want pandas. Now, sometimes in unusual circumstances, you might want geopandas, but unless you know you want it, really you want pandas. And pandas comes with the read CSV, and pretty much you do pd.read CSV and get your file as the data frame, and then everything else is like we showed in the introduction. By the time you have a data frame, so it would be pd.read CSV, and then you just put the name of the file there, and then you do this. And depending on how complicated your data frame is, you might get garbage out of this. It'd be an HP plot of everything, all the columns in the data frame, and it might not make any sense whatsoever. And at that point, you need to select, you might select dd.crime or whatever, df.crime, something, you might select particular columns to plot or a subset of columns and so on. So there might be some steps in between getting it into your CSV and actually what you want to plot. But if you look at our examples online, you'll see lots of examples of starting with a data set, seeing dozens of columns, picking a few to choose to focus on, and then going from there. In particular, if you look at the HP plot, just the user guide for plotting, it'll start with various pandas data frames, something like this. And you'll need to select individual things to plot, and that's what happens in these later, like in this case, it does a line plot of the year on the x-axis and the crime rate on the y-axis. And where did this come from? These are just columns in your data frame. And where did those come from? Well, at bottom, they were a CSV at some point in some time. So if you've got these are comma-separated values, they have labels on each of the columns, and then you just end up writing a line like this. Pick any column and plot it against any other column and go from there.
Awesome, thank you.
I'll continue this question. Let me rephrase it a little bit different. What if you had this data, but you had it per state, like crime per state? In the past, in HoloViews, you had the ability to actually show each state in a different color by one line of code, and the ability to change it and to have like a drop down and show each plot differently.
Yep, that's all still there. In this case, you do group by equals state. If you had that, if there were a column, if one of the columns showed you the state, so you had some data frame, let's go back and see, here's some data frame. If there was an additional column called state, and each of these has some value for the state. Then you would do a group by state, and then you'd automatically get the type of widgets that I showed later. HoloViews would figure out the widget and use that to plot it. And all of that is covered in the plotting library. There's probably one here. Let me get to it. Not on this page.
So hvplot supports whatever HoloViews does?
Pretty much. HoloViews is a strict superset. Oh, here's one. So here it's grouped by day of week, and you see that we got a day of week slider. So I finally found one. So if you here it's overlaying by carrier. I don't even know what that is. This is flight delays. It's overlaying a bunch of it's doing a bunch of plots by carrier, and it's grouping it by day of week. And so this is roughly the same power as you get with HoloViews. All of it eventually is implemented by HoloViews. There's no special magic at the hvplot level. It's just a different API for HoloViews. And there are some things that you need HoloViews for, not in this case. There are probably some good examples. I don't have them immediately, but let's say if you wanted to lay things out next to each other, you would use HoloViews tools to do that. You would use plot plus plot, and then that'll show things next to each other. Probably that's, well, I'm sure that's in here. So at some point you can run out of things that are supported at hvplot, and then you just reach for the thing in HoloViews if you need that. So you can get by without learning anything about HoloViews, and if you want more, how do I do that? The answer is almost always, okay, here's how you do it. You go look at this other site and you learn how to do it.
And one more thing that James didn't mention, but HoloViews, he showed bokeh, but HoloViews can accommodate other plotting libraries, correct?
HoloViews can. Nobody's written, what hvplot does is map from matplotlib options onto HoloViews options. And it's only been written once. We could also write an hvplot that maps from Pandas matplotlib options onto plotly options. And then it would support plotly. We haven't even written one that maps from matplotlib options in Pandas onto HoloViews matplotlib options. We haven't written that. That would be pretty easy, but we haven't done it. So that's why I only mentioned bokeh. hvplot only supports generating bokeh plots with all the correct options. If you want to abuse it, you can totally use it to make matplotlib plots, but it is kind of an abuse, because that means you have to, instead of taking the Pandas option and having it map, you'll have to do that yourself. Like if you wanted to set the width on it, you can get the HoloViews object and then set the width on it. You can totally do that. But normally with hvplot, you don't have to do that, because you supply the width immediately to Pandas, and then hvplot translates it down to the back end. Sorry if that doesn't make any sense. It probably won't.
No. So just to explain, what James does a lot of times, the entire group, they map from one library to another, so you will have one common interface.
Mm-hmm.
And all of those names that he just mentioned, basically there is one place you go to, and you can use all of the power of the other libraries many of the time. Sometimes not. This is what he basically said.
That's right. And hvplot is the one case where we have not done this. We have not supported anything but bokeh. So if you go to HoloViews and look at any of our reference gallery items, you can see that it's got a plot. Well, that's a bokeh plot. But then you go click on what's the matplotlib equivalent. Okay, well, there's the matplotlib equivalent. What's the plotly equivalent? There's the plotly one, and so on. So they each have their own things they support, but they all have the same syntax. And so it lets you not have to commit to a library to do your final rendering until you usually have one by default, but if you find something that's only supported in Plotly, or you need it to look like a matplotlib plot, then you can choose that later. But not if you use hvplot. hvplot only supports bokeh. But we'd be happy to take money from anybody who could do that, or who would be willing to put in that work. We just don't need it for our own work, so we haven't done it.
Okay. Any other questions?
Hey James, I have a question for you. Suppose I want to overlay like a fixed or independent baseline on top of like a graph. So say I have like a histogram of like the heights of people in a certain group, and I just want to overlay like a red line that's like a Gaussian curve, just to show like what the baseline is. How can I do that? And if yes, how?
That is, let me finish my burger here. What you want are annotations. Where are they?
You're in HoloViews, not
Yeah.
hvplot.
I know, that's actually the next point. HoloViews offers things like horizontal lines, various annotations like that. And so what you do is you grab your hvplot output, and then you do this. So right here where it says it's hv.points, that could be anything you get out of hvplot, anything you could see ever, and then you add this little bit to the end. This little operator means overlay, and then you add a horizontal line, an arrow, some text. So the annotations that you can easily add will be like an arrow. That's actually an arrow plus some text. You can add a horizontal line, a horizontal span, which is a whole area. A vertical line here somewhere, vertical line, vertical span, a bit of text, and that sort of thing. So that's actually a theme in our work, which is that the simple tools should never be a dead end. And I hope I have oh no, it's the introduction here.
Here's a horizontal line you overlaid. A vertical line with some text. Here it is.
Oh yeah, vertical line from text. That's right. But I was actually looking for a polemic that I wrote, but I guess it's not there. Oh, it's under background. That's where it is. So I'm looking for this plot right here, which is what motivates us and why do we design things the way we do. hvplot is a high-level tool that allows you to get from nowhere to something immediately and very quickly. But I hate that if you get there very quickly and then you have a dead end and you can't get where you need to be. If you need it customized for your thing, if you need to have a little overlay, let's say, or a little annotation or a little something, just a little something, and fiddle with it. It's super frustrating when you're using a high-level tool that doesn't allow you to do that. But it's also super frustrating if you're using a low-level tool where just to get a plot, you have to make 100 decisions and choose everything. You have to be an expert just to get anywhere. And so what we try to do is on the right here, we try to give you high-level tools like hvplot that get you pretty close. And then you only have to learn one or two things. Like you have to look up, how do I add an annotation to my hvplot? Oh, okay. I need to use pull in HoloViews for that. That's one of the cases where you can't get it in hvplot. Actually, you might be able to. If there is, I don't know it. And I know HoloViews, so I just reach for that. And so you learn a little bit about HoloViews and about overlaying, and now you can get to exactly the plot you want. And look how many steps you've saved, as opposed to something that gets you close, but you can't use it in reality because you always get stuck in some dead end. So I call this principle shortcuts, not dead ends. You want to make a shortcut, but you can't be a dead end or you're just doomed. It's unusable. So shortcut followed by some little extra work on your part. You have to learn new stuff, try new stuff, and then you can get to do exactly what you want. But you don't have to learn the entire space of everything. That make sense?
Yeah, that was a great answer. Thank you. And I really like that graphic and philosophy.
So, but anything you see in HoloViews, you can immediately overlay or combine that. Like you can put ellipses, you can put any of these things on top of your hvplot. Even if hvplot doesn't support it, all hvplot does is give you a HoloViews object, and with any HoloViews object, you can combine it with any other HoloViews object in this way. That's the bigger answer.
Florian, can you read the next challenge that someone written? Because I cannot read.
Yeah, that was something to recommend too. So, Sherry is asking if you can map the number of livestock per geographical region. So that's something that I'd like to see something with like a geospatial, like anything geo.
All right. Well, GeoViews is your go-to point for that. So we just showed the overlay operator. That's the star. And so this plot right here is actually an overlay of 4 items. It's an overlay of a database that shows the locations of the ocean, another one that shows the locations of the land, another one that shows the outer coastlines, and another one that shows the borders. And you can plot any of these individually, and this is what you get for ocean and land, or you can plot them all together, and you get this plot. And you get this particular round shape of it because you've chosen this projection, the geostationary projection. You can choose all sorts of other projections. There are a lot of them. None of them are perfect. All of them have their own problems. You're basically flattening a round shape onto a screen, so you have to deal with it. But you can choose whatever projection you want. And that's the main thing that GeoViews gives you that HoloViews doesn't have, which is the ability to this projection argument. And this is for the display projection. There's a similar one called CRS, which is about declaring what your data is in. What is the projection your data started in? And then this is what do you want your data to be projected into? And then with GeoViews, this is, GeoViews supports gridded data, polygon data, pretty much anything. The gallery here, I think GeoViews gallery is fairly complete, but it only includes the things that are geo-specific. So essentially, you use something from here for your geodata, and then right next to it, you put something from hvplot or HoloViews to go with it. And actually, what I should have mentioned is that hvplot will automatically call GeoViews if you pass in, if you tell it it's geodata. And so if you pass this in, it'll look for latitude and longitude, and it'll convert those into whatever what your output projection is. And so you can use hvplot with your geodata, whether that's points. You have to first declare what your
Simulation might be done.
data is in. I don't know where that was. Oh, it's right here. It's just talking about that. Anyway, once you've declared what your data is in, you can then take that same data and overlay it on any other data, and it'll automatically reproject everything into the final output coordinate system.
Yeah, so I think, Sherry was asking if you can plot real-time weather, hurricane data, and I have actually a decent question for that. Is like how much data can you stuff into that graph? Like, is it there like is it like machine limited, like?
Yeah, if you look, it's limited by basically your memory. So I thought there was somebody who just probably, they didn't use data shader. So the data shader lets you handle anything that could fit in your memory or in any number of memory of worker machines or processes. So what data shader does is render everything off screen, and so you can have an entire supercomputer at your disposal. And we work with a lot of climate scientists. You can learn a little bit of our work at pangeo.org. If you look at some of their examples, you'll see they're using HoloViz tools throughout. Looks like Pangeo is down. That's very bad. Pangeo they use a lot of climate simulations and satellite imagery. And so these are petabytes of data, and they have supercomputers to crunch them on. And in the end, though, you crunch it down to an image that you can display. And that's what Data Shader will do for you. Give you an image, and then you can, here's somebody who's posting their image data set. I don't know what they're working on. It'll give you something that your browser can handle by rendering things off screen. So this is one made on my particular machine. It takes about 1/10 of a second, renders 300 million data points. My machine will handle about 1 billion with the memory I have. And if I need more, I just need a cluster or a set of nodes that each have their own memory, and then use Dask to coordinate, and then all the tools, hvplot. Dask is one of the things that hvplot supports. So if you look at this list of all this stuff here, if you use Dask, Dask will let you handle arbitrarily large data. You just have to keep buying more and more hardware.
Yeah.
So hvplot supports this, like it gives data from data shader or not?
Yes, you pass in, that's probably in here somewhere. Let's see.
I know HoloViews does.
Yeah, so in hvplot, you pass the keyword rasterize equal true or data shade equals true, and it must be just part of the regular, let's see, data shade. Yeah, it's already here. So if you pass in this this keyword data shade, it'll call data shader automatically on the data before it hits your browser. And so that if you use, I would recommend using rasterize equals true instead of data shade equals true. Data shade rasterizes your data into pixels and then colors the pixels, whereas rasterize only does the first step. And when you let bokeh do the last step, it'll give you hover information. So you can use either one, but anything you can show with hvplot, if it's too big, if it crashes your browser or slows things down, don't worry about it. Just type data shade equals true or rasterize equals true, and it'll be highly practical.
Nice. Yep.
Any more questions or challenges?
It's hard to stump me, but if you really want to, it'd have to be something in a 3D direction. We don't do much of that.
Okay, Sherry says yes. Must be a challenge coming out.
All right, go for it.
The overlay hospital bed capacity versus patient needs in crisis zone. I mean, you probably can do everything, right? Like, if you have the data.
Now you can plot anything against anything. You just figure out what to type here, what to type here, and what to type here.
Yeah, I mean, that's, once you have the data, and then it's structured in the right way, then you can.
Yeah, the hard parts are when your data is a mess. Like if it's not structured very well, that's a lot of job. If it's dirty, if it's full of messy values that make them mess up your plots. Data shader actually is very resistant to those and doesn't get messed up, but other things do. Those are problems, and often it's just a problem of figuring out what to plot against what.
Oh yeah. Oh yeah.
Yeah. And a lot of times, I mean, if you really want to be a data scientist, you're not just plotting your data, you're terribly manipulating it. For instance, you run a machine learning algorithm on it. What you get out of that algorithm is very different from what you put in. You need to visualize every step, and that's a lot of knowledge and understanding of what you're doing that's required there. It's not just about plotting. Here, we're only talking about once you have the data.
Yeah. I used it in the past, those tools, to show whatever happens internally in the neural network, like the layers of the neural network during training. You can do that.
Yeah, that's where we started. My original group at the University of Edinburgh was a neural network research group, and we're doing brain modeling and need to understand and visualize what each little stage of this deep network is doing. And so that's actually how HoloViews got created. It was frustration with trying to use the matplotlib API when we really needed to look flexibly at all sorts of data from all different types of experiments, simulations. It was just so painful to plot every new thing each time, and so we made it be super easy. And then eventually that entirely ruined our research program because we became tool builders and never did any work again on research. So I don't know that it certainly didn't help our research program, but the world got a bunch of free tools.
I'm happy for that. This is successful. Successful use of money, research money.
Mm-hmm.
I think so. I've seen many other cases. This is actually
yeah, the whole first half of the program was funded by the NIH for brain science.
Huh. Well, I'll tell him next time I meet him with the NIH, the brain scientists.
Yeah, it was part of the Human Brain Project. I don't know what else came out of that, but this did.
Okay.
Question: is there anything in these libraries that would help, like, colorblind people see the?
Color set is where we have a collection of color maps. It does not have a particular focus on colorblind friendly maps, but some of these are colorblind friendly, and it has links to some other ones that are more colorblind friendly. So let me see. All of the ones that are included with matplotlib are colorblind. Sorry, all of these four are the four that are kind of the focus of the perceptually uniform ones in Matplotlib. So there's, where are those? These are all good colorblind friendly maps. And if you'll notice that the same color map doesn't include both red and green. And that's that at least covers most of the typical male linked colorblindness. So any of these are very good choices for that. But there are a lot of people who've done a lot of work on it. All of these tools can use Matplotlib, Bokeh. We can all use, any of these tools can use color maps from any Python library like that. So there are lots of people who have, they're actually listed here, PyViz. So if you go to pyviz.org, I think part of this site is down. A lot of these links are broken. We're working on it. But if you go down to the color mapping section, a lot of the ones in the VISCM, and actually I've added 2 more that haven't shown up on the website yet. There are a couple more packages that'll be listed here soon. These all have lots and lots of colorblind friendly maps.
3D avatar modeling, Sherry asked.
What kind of modeling?
3D avatar modeling, this is what she asked for. Well, he said not 3D, Sherry.
There is some 3D stuff particularly at Panel. So if you look at the reference gallery, the gallery.
Yes.
Yeah, so you can model. So we can certainly handle 3D. We just don't focus on it.
Okay, she reduced it to 2D avatar modeling.
Okay, sure. So this is 3D stuff in a Panel app. But basically, this is just embedding some externally generated 3D content and showing you can put it alongside all of our widgets and so on. But it doesn't give you much power except it allows you to integrate it. So in terms of 2D avatar modeling, if you can have anything that generates images, it's pretty easy to integrate it in here. I would actually use this library of ours that we created for neuroscience, which is Imagen. It's hard to type when you only have one hand because the other one's got fries in it. There we go. So this, I actually have a little thing on here to draw human faces, very ugly ones. So hey, we could. This is parameterizable, and each one of these can be a panel widget immediately. You can just call panel on this whole thing, and you'll get widgets for all these guys. And then you can have a little. Do you want to move the eyes closer together, further apart, size of them, and so on? So sure.
Whoa! I didn't think that you'll answer this challenge. Whoa!
I'm old. We've been doing things a long time.
Yeah. This is what happens when you're doing a lot.
Yeah, this library was written before HoloViews, before Panel, before hvplot, but it still works together with it. It all just works.
Whoa. Okay. We have been doing it for a while, I think. Okay, I had some more challenges earlier. Okay. Sherry threw a lot of challenges at you today. Unless Florin can pick up another challenge, then and unless someone has any more question, I suggest that we let James eat properly because
I'm done, but my wife is ready to see me, so I should go.
Okay, guys. We should maybe thank James for his good presentation. So I'm gonna clap. Everyone else do whatever. You can unmute yourself, put something nice. I think we challenged him enough today.
Not enough. You can break me.
No need. Next time we'll break you. We'll promise. Hopefully, we'll have a next time with you. James, thank you so much for showing you this. And I didn't tell James I'm throwing challenges at him today. and still he accommodated all of these. So again, thank you, and thank you for all those great libraries. Personally, I want to help you because I use them, but I hope many of you who are listening will use them. They are very good.
Thank you, and they're all free. Download and enjoy.
Okay,
Thank you.
I'm going to stop the recording now, unless you want to say something, Florian?
No, I said thank you. Yeah, that's awesome. I think I have some ideas on how to use
Okay.
it. So.
Okay, I'm going to stop the recording now, and stick around. We're not going anywhere.